Good evening to all of you. So today is our lecture, week 12, and the lecture. Walaikum Salam. Walaikum Salam. So our main lecture is decomposition. Today is our lecture, and the topic of today's lecture is decomposition. So we will discuss one by one the decomposition method. So I'm going to upload the PowerPoint slides. So before I start with the final lecture, I will give you some preliminaries that we discussed, that we know from the previous weeks. We know that how we can add the matrix, how we can uh, eliminate using the row echelon form, how we can convert the matrix into the row echelon form, and what are the elementary matrices. So there are some previous things. After that we will come on the main topic, that is LU decomposition. So here the row, what is a row elementary matrix? This is a definition of row elementary matrix. A n cross n matrix is called n. Wait a minute. Yes, I'm fine. No, I don't have. The exam is completed. Right now, I'm in a class. Yeah, I'm in a class at the moment. It is a virtual class. I'm at home. I mean, which class the students? No, but I don't have any information about that. So let Dr. Ali do one thing. You are at the department. Okay. Hello, welcome back. Sorry for there is some delay. So we are discussing that there is a matrix, elementary matrices. I'm discussing a row elementary matrices, and n cross n matrix is called the elementary matrix. It can be obtained from identity matrix. There are some operations. We know we can convert the matrix into row echelon form. There is a matrix if we interchange any two rows, if we can multiply any row by a non-zero constant and add a multiple of row to another row. There are some operations that we know earlier. So either we can write like this or we can do anything. These are operations we know earlier. So there are some operations that we can convert into the elementary matrix and not elementary matrix. These says that what are the elementary matrices. So we say that yes, it is an elementary matrix because we convert this matrix into the elementary matrix. If we divide row 2 by 3, then it can convert into the elementary matrix. So what about B? B is not an elementary matrix, identity matrix, because it's a 3. It is a 2 by 3 matrix. Because of we know that if we have a square matrix, then we can convert into a unit matrix, but it's not a square matrix, so it is not a unit matrix. Similarly, over here, if we find it, there is a whole 0 0 0, so it is not a row matrix. It is not an identity matrix. Similarly, in the case of D, we can convert. It is not a right now. It is not an identity matrix, but we can convert row 2 into. We can convert row 3 into row 2. Then we can get the identity matrix. So in the same matter, we know earlier that we can convert any matrix into the identity matrix or any form. So representing elementary row operations. Let E be the elementary matrix obtained by performing an elementary row operations on IM. If that same elementary row operation is performed on an M cross N matrix, then the resulting matrix is given by the product EA. So there are some operations that we know. These are some operations of the elementary matrix. So using the elementary matrix, we can find these are matrix. Find the row operation one by one. We apply on a row operation 1 2. We apply. We convert it into this, and finally we get 1 0 0 0 1 0 and 0 0 1 by 2 either one. So these are the operations we know earlier. So this is called the row echelon form. If we convert it into the identity matrix, then it is formed the row echelon form. So if E is an elementary matrix, then E inverse exists and is an elementary matrix. So elementary matrix and inverse of the matrix. If, for example, there are some example, if E1 is an elementary matrix, then if we are going to inverse it, then we just inverse both sides, right side and both left side, and we get R12 is equal to inverse is equal to 1 0 0, the same matrix. So similarly, in that case, we can do the inverse on the both side, then we get the inverse. Similarly, properties of an invertible matrix. A square matrix A is invertible if and only if it can be written as a product of elementary matrices. So find the sequence of elementary matrices whose product is this. So there are, if A is this, sequence of elementary. So first operation we apply on R1. What we apply, we are going to multiply -1 over here, and again time we apply the operation on row 1 2, because of we want 0 in this place, so we apply row 2 and subtract -3 on over there. So this is the idea to write here. So finally we convert into the identity matrix 1 0 0 1. So therefore if they combine all these things, R12 R21 R31, combined all these things, so we get A is equal to I. So this is the method. So an equivalent condition of if A is an n cross n matrix, then the following statements are equivalent. If A is invertible, Ax is equal to B has a unique solution for every n cross n column matrix B. So these are some things that we know earlier. Now we come to our main topic, that is LU factorization. So decomposition, or we can say, so as we know that in a face-to-face class, I told you there are three types of decomposition. First one decomposition is called the LU decomposition, and the second decomposition is called the power method decomposition. So now, first of all, when we discuss that what is LU decomposition, it says that if we have an n cross n matrix, A can be written as a product of the lower triangular matrix L and the upper triangular matrix U, then A is equal to LU is an LU factorization, where L is called the lower triangular matrix and U is called the upper triangular matrix, and A can be written as A is equal to LU. So a square matrix A can be row reduced to an upper triangular matrix using only the row operation of adding a multiple of one row to the another row. Then it is easy to find an LU factorization. So as we see in the previous, to we have to find row operation one by one. E1 we find, E2, and we find E3. Finally we get whatever we get U, and if we multiply all these things we get the lower matrix. So in a face-to-face class, if you remember that what I did in a class, because of in PowerPoint slides there is a little bit, they use a different method, but in my face-to-face class I use the method that is over here. First of all, we have to draw some matrix like cross 0 0 and cross and cross and 0 and cross and cross and cross. So because of it, this is this is L, lower triangular matrix, and we have to find this lower triangular matrix. So automatically we basically, when we apply the operation, then we can find both the operation, both the matrices like U as well as L. So this is a method to find the L and the row echelon form. From the row echelon form we can find the U. So we can see there is this equation, LU factorization. There are two examples. One example, A is equal to 1 2 1 0. So we apply the row operation one by one, and we have to convert it into the upper triangular matrix. So we apply it. This is a and again we apply it. This is an when we apply the operation on R12, then it will, because of we want 0 in this place, so it will become the upper triangular matrix, and this is an upper triangular matrix and we want the lower triangular matrix. So in the process, they use a different process, but you will do my process as I done in a class, that like a cross cross. So if we do that process, you can find that it is a lower triangular matrix. So L as well as U. So similarly, in the same process, this is a matrix and they apply the operation, and they want the row, it will reduce the upper triangular matrix. So they want 0 in this place, they want 0 in this place, they want 0 in this place. So they will convert this matrix into upper triangular matrix. So this is an upper triangular matrix because of all the elements below the leading diagonal are 0. That is why it is an upper triangular matrix. And now we have to find the lower triangular matrix. So you use the same operations that I did in a face-to-face class. one by one you have to put cross cross cross. You will check out how we can cancel the cross, and in the same manner after 3 steps you will get the lower triangular matrix. The lower triangular matrix is this. You will get this lower triangular matrix. uh, so you will get this lower triangular matrix. So this is L, and and this is we get whatever we get. So combine all this thing. Lu is equal to, so solving Ax is equal, so solving Ax is equal to B with Lu factorization of A. Ax is equal to B. If A is equal to Lu, then Lu is equal to B, or Ux, then Ly is equal to B. There are 2 steps. Write y is equal to, it says that write y is equal to ux and solve ly is equal to b for y. Solve ux is equal to y for x. So solving a linear system of using LU factorization method. So if we have given a linear equation, so first of all we have to convert this linear equation into the a matrix. So the coefficient of x1 is 1, we write here. The coefficient of x2 is -3, I write here. And the coefficient of x3 is 0, so I write here. So similarly, I write the whole matrix over here, 0, 1, 3, and 2, -10, and 10. So and after that, the I apply the row echelon form, and I want to convert it into the upper triangular matrix. So I want 0 in this place, 0 in this place, and 0 in this place. So applying the row operation one by one, I will convert this matrix into an upper triangular matrix. Now let the as step number 1 in a previous, it says that y is equal to ux, and solve ly is equal to b. So y is equal to ux, y is y1, y2, y3, and ux, and it says that 1, 0, 0 we obtain from the matrix. So 0, 0, 1, and this is an lower triangular matrix, and this is an upper triangular matrix. So y is equal to ux. So with this help we will solve it. When we convert it, y1 is equal to -5 and y2 is equal to -1, and adding them combined, y2 y3 is equal to 2y3 is equal to -5, and just combine all them, and we will get like this. We will solve like this: -20 -2y1 plus 4y2 is equal to, just add them and we will get -14. So, and next step is solve the following system: ux is equal to y. So when you are going to solve this, x1, x2, x3, so one by one you will solve it. First you will start from x3, or you will x3 is equal to 14, 14 is equal to minus 14, so x3 is equal to -1. Similarly, just to go back upper side, minus this, and again solve this. X2 is equal to -1 -3 x3 by back substitution. Yes, you are right, by back. And similarly, just to go back over here and then find the value of -5 plus 3 2 is equal to 1. So thus the solution is 1, 2, and -1. So the next thing is, what are eigenvalues and what are the uses of eigenvalues in this. In linear algebra, we learn that the scalar lambda is an eigenvalue for the square n cross n matrix A. If there is a non-zero vector W, such that AW is equal to lambda W. We call the vector W as an eigenvector of the matrix A. The eigenvalue acts like scalar multiplication instead of matrix multiplication for the vector W. Eigenvalues are important for any application in mathematics, physics, engineering, like any other thing. So, what is a dominant eigenvalue? A n cross n matrix A will have n eigenvalues. Some may be repeated by the dominant eigenvalues. We refer to the one that is biggest in terms of absolute value. This would include any eigenvalue that are complex. So for example, if we are going to solve this equation, this matrix, then we have to find the eigenvalue. Then we are getting the eigenvalues. The matrix A is the right has its eigenvalues, the set of numbers 1 minus 4 and 2. Because of we know that when we have upper triangular matrix or lower triangular matrix, then this is a theorem that the eigenvalues are its diagonal elements. So the eigenvalues are 1 4 minus 2. That is the upper triangular. In absolute value, we have to take the absolute value, that is 1 4 minus 2. So 142 is the eigenvalue. So which one is the largest? 142. So we observe that the 4 is the largest. So we say that 4 is the dominant eigenvalue. It is called the dominant eigenvalue. The problem we want to solve is that if we are given a matrix A, can we estimate the dominant eigenvalue? So now with this concept, we are going to introduce the power method. So the power method says that the power method works for the matrices sort of like how the fixed point method works the function. The iteration step is a bit different though. To explain how it works, we need to introduce a bit terminology. The dominant term of a vector V is the term that has the greatest absolute value. Careful, it is the term self, not absolute value of the term. If there are two terms that have the same absolute value, you can pick either any one of them. So these are the eigenvectors V1, V2, V3, V4. These are some eigenvectors. So in these eigenvectors, the dominant value is the maximum value. Which one? So 7 is the maximum value. So we say that the dominant term is 7. So in this eigenvector, which is the dominant term? The dominant term is minus 8. Because of there are two terms, minus 8, minus 8. So choose anyone. We can choose either this, either this. So we choose anyone. So in this, the maximum term is minus 10, and so the dominant is minus 10. Similarly, the dominant is 6.5. When you just count it, the bigger one is 6.5. So the algorithm consists of the following steps. Start with the initial vector W naught. Let the approximation for the dominant eigenvalue be Z naught. The dominant term W naught, use iteration on the right side. So there is an example that shows how we work with the power method. So the question is, apply the power method for 3 iterations. And in a class, face-to-face class, we use the 5 iterations, but here they say just for the 3 iterations to find Z3 and W3 for the matrix A is given. This matrix is given, and they say use up to 3 iterations. So it says that find the eigenvalues and eigenvectors W naught is equal to 1 1 1, and Z naught, choose anyone. Which one is the bigger? So anyone we can choose. This is one, this is one, this is, so anyone we can choose. So we choose Z naught is equal to 1. So first iteration is AW naught. The first station is AW naught, second iteration AW1, third iteration AW2. We will find one by one. So we will multiply AW naught. So the value of A is given. The value of A is given in the inside the question, and the W1 is the eigen, W naught is the eigenvectors. We find it, and you are going to multiply 0, 1, 2 with this first row, first column. When you are going to multiply, you will get 3. Similarly, second row, first column you are multiply, you get 2. Similarly, third row, first this column you multiply, you will get 3. So this is the value that we are getting. So just divide the whole this vector we are getting. So just divide the whole vector by 3. If we divide 3 by 3, we get 1. If we divide 2 by 3, we get 2 by 3. If we divide 3 by 3, we get 1. So we get this next vector, that is the next eigenvector. And now choose which one is greater. So we observe that the 1 is greater. So here they use z1 is equal to 3. Either you can use 1. So because of here we divide it by 3. So that's why he used z1 is equal to 3, because of 3 is the greatest integer. So next AW1. So again our W1 is this, multiply A with W1, and we get first row and first column. We get first row, first column multiply, we get 5 by 3. Similarly, second row, first column multiply, we get this element, and third row and this multiply, we get with the 3 element. So which one is the greatest? So when you see it, when you divide something, you will get like this, and there is a which is the greatest element in this vector. The greatest element in this vector is 3. Similarly, after that you will do again AW3. So again solve it, and you will find it that Z3 is equal to 2.7. So one by one you will solve it. So then similarly in the same pattern. So this is the power method convergence. The power method will not converge for a real matrix A. The power method will converge to the dominant of eigenvalue if the dominant eigenvalue is a real number. If the dominant eigenvalue, do, dominant means the same thing that I use, which one is the greater. If we have 3 vectors, 1 3 1 3 1, so the dominant value is 3, which is the greatest one. It is called the dominant value. So how this convergence can be seen as follows. So there are some mathematical languages given. You will see there are some with the, because of I use the examples, you can see the theorems with the proof. Yes. So now the last thing is the singular value decomposition. Matrix rows, point vectors, Euclidean space, the two objects. Yes, of course. Two objects close. Only this week is a little bit harder. If you see, the next week is very easy, and its PowerPoint slides are very effective. Because of its LU method, LU decomposition method, I found many places and I'm unable to find any suitable PowerPoint slides. So it's better for you. You will concern with the book. because of I hope that in the book there is a good material available, but in PowerPoint slides, I'm not giving you to go in this PowerPoint slide because of this LU decomposition method in book a little bit easy, because of it's a long process, is long, so that's why the PowerPoint is uh, so we will see the singular value decomposition. So what is the background of singular value decomposition? So let the blue circles represent M data points. If we have a scattered data, like these points are the data, if we have data like over here from bottom to top, so it says that then the singular value decomposition M may be maybe two matrix of the data will return. So first write singular vector direction to the maximal variance. Second write, yeah, this is the first right. How much data will be scattered from bottom to up, and this line is says that how much data is distributed from there one side to another side. Direction of the maximal variance after removing the projection of the data along the first singular vector. So this is called as sigma 1, and this is sigma 1, and the length is called as sigma 1, and the width of the data is called the sigma 2. Sigma 1 measures how much of the data of variance is explained by the first singular vector, and sigma 2 measures how much of the data variance is explained by the second singular vector. So, and this is a formula of the singular value decomposition method, and this says that M cross, if we have a M cross N matrix, then it is an upper triangular matrix, and it is a summation, and it is a vector. It is a whatever we get eigenvectors and the transpose of the eigenvectors. So in this way we can write the final decomposition. So it says that with this figure, it says that A is equal to U upper triangular matrix, and it is a summation of whatever is only the diagonal element of the matrix, and V is a significant noise. In this is the formula of the singular value decomposition method. So if it says this is the formula is written M cross N matrix, M upper triangular matrix is a M cross K, and summation is K cross K, and V transpose is equal to K cross M. So there are some issues. The singular value decomposition and CCA are often used to summarize and approximate metrics, and they have enjoyed the enormous success in the data analysis. And for the large graphs, they requires long amount of memory, exactly because the resulting matrices are not sparse anymore. So there are some results you will see on the book. Only that's the end of the chapter. You can see, but I prescribe you will check the book also, because of in a book there the idea is little bit good. So any other question? We will try to solve these problems at your home. Homework will be the last one. I can't understand which one. Last one. What is the last one? Which one is the last? Week 12. No, the homework I provide you the yes. This is the last homework. Week 12 is the last homework. And week 13, I'm not giving you the homework for week 13, just because of it is a last homework. You have to submit it before yani before 10th of May. Before 10th of May, you have to submit all the assignments, all the homework. Okay. And any other question? The bonus marks, as I told you, the bonus marks I will provide you the first week of May, and yani after next week I will provide you the bonus marks, uh, and still I am not getting any criteria because I will give you the 10 bonus marks, and the criteria still I cannot define. Maybe I will give you the assignment, and you will submit the assignment, then I will give you the bonus. So I will tell you in the next week what is the criteria of the bonus. So you will work hard and prepare the exam, because of after few weeks, couple of weeks, you will get a final exam. So okay, good night and take care. Sure.